Welcome! In the remaining part of our course, we will be trying to use Apache Spark with Cassandra in batch fashion and streaming fashion. But before we will start to do this, we need to understand how Apache Spark works. In this 8th section, we'll be looking at the overview of Apache Spark technology. So firstly, we'll see what is Apache Spark and Spark architecture. Then we will be trying to create a project in Apache Spark. We will be seeing an example of working with RDD and data frame, and we'll be setting up the Spark connector to Cassandra database. And in this first video, we'll be looking at the what is Apache Spark and the Spark architecture. So we'll be see a Spark architecture, what a resilient distributed dataset is, how partitioning works, and we will see that transformations and actions and laziness of transformations in Apache Spark. So let's look at the Spark architecture. We can see that there is a one Spark driver application that can connect to multiple Spark workers. And when we are writing code, the code is the same for driver and worker, and for us this is transparent which part of code will be executed on driver and worker, but we need to be aware of those facts. And under every Spark worker there could be a data node from HDFS because Spark worker need to write some data to HDFS. And in Spark the main building block is a resilient distributed dataset. This is a distributed collection that is working on multiple nodes and is a transparent thing to us, which part of that correction is executed. All RDDs are immutable, and it has a friendly collection API that we know from the Java world. And every worker is processing only a small part of the data set. Datasets fault tolerant, so if something bad is happening, so we need to restart our worker, every operation will be resumed from the point where the failure occurred. And let's look at the example. So let's say that we have a list of ABC elements and we want to process those on 3 nodes. And Spark driver using partitioner will execute that in parallel. So the A element will be executed by the first Spark worker, B element by the second Spark worker, and C element by the third Spark worker. Every RDD is immutable, so if we are creating some filtering operation, it will create another second RDD. And if we are mapping some elements, it will create RDD, and we can see that third RDD has a pointer to second RDD, and second RDD has a pointer to first RDD. And Spark is fault tolerant. So let's get back to our example of processing a list of 3 elements, A, B, C. So let's say that Spark driver is executing A on worker 1, B on worker 2, and C on worker C. And something bad is happened to worker, third worker, so there is a crash, and after crash that worker will restart, and the value C will be recomputed by that worker. It could also be recomputed by some other workers if processing of element A on or B will finish. And Spark is partitioning data similarly to Cassandra. So dataset is broken into partitions. So let's say that we have a dataset of 30 elements. And according to some partitioner, the first partition is from 1, 2, 3, 4, 5, 6 elements. Then second partition is 7 and 9, 10. Then third partition has following 13 elements, and last partition has 6 elements. And using that partitioner, some parts of processing will be processed by worker first worker, second, and third. And in Spark we have 2 types of transformations or actions. Transformations are not invoking actual computation. So if you are flat mapping, filtering, grouping, reducing, or mapping values, then this transformation is lazy. It is lazy until we will execute some action that will trigger actual processing of our RDD. So if we want to take n first elements, or if you want to collect that or count number of elements in RDD, or reduce that is computing some return value, or top or take ordered, it will execute invoked all transformations that are defined in RDD. And this is an example that we have RDD and we are defining multiple transformations and it will create new RDDs. So for example, filter. Then we are creating some text file. So this is an action. And after that, we are counting elements and it will create new processing and execute Spark program.